Okay, so now let's take a look at a quick example. But before we do that, I just want to quickly look over the equation and what it looks like when we graph it. So we said that the function, the electrostatic force, when we graph it proportional to Q1 and Q2, it's going to be a linear line because it's directly proportional. When we graph it in terms of r, the distance, we're going to see that it looks like the inverse square function. And in order to straighten that out, there's not much value like we can get from this graph, because unless we have calculus to solve for this, which I guess we do, but in order to use just linear algebra in order to solve this, we can instead straighten the graph. And by doing this method where we graph the square of r, then we can get a linear graph and we can find the slope in order to find the value of k. So just a big recap here. So the force is directly proportional to the masses if it were in gravity, and the force, quite similarly, is directly proportional to the charges if it's in terms of electricity, which is what we're doing. If it's the distance, it's going to be inversely proportional by its square. So let's take a look at this question. So two identical charged spheres are at a distance r apart. So let's just draw that out to see that in action. So here's one sphere and here's another sphere, and it's going to be at a distance of r. So it has distance in between them, r, from its centers, something like that. And we want to find out what the force is when that distance is changed to 2/3 of r. So the distance basically gets smaller, which means the force is going to get a little bit larger. So out of these options, you can see that C and D are probably good fits for this answer because we're seeing that the force should get a little bit larger. And so let's take a look at what the answers could be. So when we substitute this in, since everything else is staying constant, the charge is staying constant, the K is obviously constant, we're just going to substitute that R into that bottom of the equation. And we're going to equate the first part of it to 1. So I'm going to do it up here. So 1 over the distance changed to 2/3 of r, which is 2/3 squared. Now let's just evaluate that, and that's going to be equal to 1 over 4 over 9. 4 over 9. And then what we're going to do afterwards is just flip it so that we can just make it a little bit more succinct for us here. So this is going to be 9 over 4. And, 9 over 4. So that 9 over 4 does not look like a 9, but it's okay. But the answer to this question is D, the fourth option, because like I said before, since we decrease the distance, the force is actually going to increase. And that's because the closer you are, so the less your distance is, the higher the force is. And you can see from this graph that that is exactly true. And every time you go further and further away, it's going to decrease. And if we're talking in terms of calculus, if the limit of this function, if it basically approaches, when r approaches infinity, that function's value is going to approach 0. So the farther and farther you get, you're going to get a smaller and smaller force.